Yeah, this is Dr. Shankaraia from Department of Physics. In this presentation, I am going to discuss Module 3. From Module 3, I am going to discuss about fiber optics. And in this, I'm going to discuss the classification of fibers. So in the previous presentation, I have discussed about classification of optical fibers, where I have discussed about three parameters that we use to classify these optical fibers. For example, okay, so we have discussed this. So based on the three parameters, optical fibers are classified. So the three parameters are, the first one is refractive index profile. Based on the refractive index profile, we have discussed classified these optical fibers into two categories: step index optical fiber and graded index optical fiber. Graded index optical fiber. So based on the refractive index profile. Okay, and then based on the modes of propagation, we discussed that mode is nothing but the allowed path of light where light waves are in phase. Okay, so based on the modes of propagation, we have classified the optical fibers into three categories: step index single mode, step index single mode, step index multi-mode, step index single mode, step index multi-mode, and graded index multi-mode. So based on the refractive index profile, you have two different kinds of optical fibers: step index optical fiber and graded index optical fiber. And based on the modes of propagation of light in optical fiber, you have three different types: step index single mode, step index multi-mode, and graded index multi-mode. Okay, based on the materials, what kind of material you are going to use to fabricate optical fiber? Based on the materials, again, you have three different types of optical fibers. So first one is glass fiber. You can have plastic fiber, and you can have PCS. So that is polymer clad silica fiber or plastic clad silica fiber. Okay. So in the last presentation, I have discussed about this classification of these three different fibers based on three parameters, and I have also discussed the propagation of light in step index single mode fiber. Okay, so in this lecture, I'm going to discuss the propagation of light in two other modes: step index multi-mode fibers and graded index multi-mode fiber. So we have now, with the basic inputs, that the classification of optical fibers based on three parameters. We have 8 different types of optical fibers, and in the last presentation, I have discussed about the propagation of light in single mode step index fiber. So in this presentation, I am going to discuss about propagation of light in multi-mode step index fiber. Okay, so this is the structure of the multi-mode step index fiber. It is clear that we are saying it is multi-mode and step index, right? So the refractive index profile of this optical fiber must be having this step index profile, because we are calling it as step index multi-mode fiber. So yeah, it is clear that the refractive index profile of this fiber is constant in the core, and it is constant in the cladding, and there is a step-like change from the core refractive index to the cladding refractive index at the core cladding boundary. So this is the structure of this multi-mode step index fiber. Okay, so this is multi-mode, so you better draw lower order modes and our higher order modes. In single mode step index fiber, you have only one mode for the propagation, one mode for the propagation, which is along the axis of the fiber. But in multi-mode step index fiber, the refractive index profile has a step-like profile, but there can be different types of modes. This fiber supports different types of modes, so there can be lower order modes and there can be higher order modes, right? So we have discussed about these lower order modes and higher order modes. Mode is nothing but the allowed path of light in which light waves are in phase, and lower order modes are the ones in which the angle theta I is greater than theta. See, they are the launching angle theta is greater than the critical angle, and these are lower order modes. modes. And higher order modes are the ones which are which are having the angle of incidence is equal to critical angle. So they will not undergo, these are higher order modes, and they will not undergo total internal reflection. We have discussed that total internal reflection occurs only when theta is greater than theta c. So those are called lower order modes, and these lower order modes, they are the fields, fields, electric or magnetic, these fields are distributed along the axis of the fiber, so the loss is very less. Whereas in the higher order modes, the fields are distributed towards the edges, and there can be more loss of light. And one more important point is that higher order modes traverse longer paths, and hence they reach with a delay time compared to the lower order modes. Lower order modes reach the output end quicker than the higher order modes, right? So with these inputs, multimode step index fibers allow finite number of guided modes, and the direction of polarization, alignment of electric and magnetic fields will be different in rays of different modes. In other words, many zigzag paths of propagation are permitted in a multimode step index fiber. So there can be lower order modes and there can be higher order modes. So there can be many different types of modes in which light can propagate. The path length along the axis of the fiber is shorter, while the other zigzag paths are longer. It's very important. So the path length along the axis of the fiber is shorter. If you have this is the axis of the fiber, and the path length is the path length is nothing but the path that light takes to traverse the output end. So this is the input end, this is the input end, and this is the output end. So if along the axis of the fiber, the path length is very small, whereas if you are taking these zigzag paths, so these ones are the zigzag paths, these zigzag paths, the path length is longer compared to this axis of the fiber. So because of these difference, the lower order modes reach the end of the fiber earlier, while the higher order modes reach the end of the fiber with some time delay. So this is what we have discussed. Okay, so this is the structure of multimode optical fiber. So it's very important to draw this structure of multimode optical fibers. Otherwise, in which you better draw these lower order modes and higher order modes. So the zigzag paths. Otherwise, it is not clear whether it is a step index optical fiber or it is a graded index optical fiber. So if it is a step index single mode fiber, you should draw only one path along the axis of the fiber, which will be clear that is a single mode, and this step index profile to clear out that it is a step index single mode fiber. But we are discussing about multi-mode step index fiber, there should be a step index like profile, and there should be multi-modes for the propagation of light. Right, so then it is clear that the structure is for the multi-mode step index optical fiber. Okay, so a graded index fiber is a multi-mode fiber, right? So yeah, so that is about propagation of the light in multi-mode step index fiber. Now let us discuss about the graded index multi-mode fiber. So a graded index multi-mode fiber is a graded index multimode fiber with a core consisting of concentric layers of different refractive index. Okay, so this is, first of all, this is a graded index fiber. So whenever we say the graded index fiber, the refractive index profile of the core is not constant. It is maximum along the axis of the fiber, and it smoothly decreases towards the core cladding boundary, and it matches with the refractive index of the cladding at the core cladding boundary. But the refractive index of the cladding is constant in graded index fiber. Very good. So this is graded index fiber, and hence the refractive index profile is like this, and it is multi-mode graded index fiber. So multi-mode means you can have different zigzag paths. You can have lower order modes and you can have higher order modes, and the diameter is around 50 to 100 micrometers of the core, and the cladding is around 125 to 140 micrometers. Okay. Therefore, the refractive index of the core varies with the distance from the fiber axis. It has a high value at the center and falls off with increasing radial distance from the axis. It decreases as we go towards the core cladding boundary. A typical structure and index profile, refractive index profile, is given in the figure. Such a profile causes a periodic focusing of light propagating through the fiber. So the size of this graded index fiber is about the same as the step index fiber. The variation of the refractive index of the core with the radius measured from the center is given by this. So mathematically, we are just giving the refractive index profile mathematically here. N of r is the refractive index profile with the distance r, which is equal to n1 into square root 1 minus 2 delta into r by a power alpha when r less than a. So this is inside core. Inside core, this is the refractive index profile. Refractive index is not constant. In the case of step index profile, we defined n of r as n1 for if or for r less than a, and n of r is equal to n2 for r greater than a. So the r less than a is core and r greater than a is cladding. R is equal to a is the core cladding boundary. Now, so this is for step index profile, step index optical fiber, and where the refractive index is constant, step index fiber. But here we have graded index fiber. That is the reason why the refractive index profile in core is not constant like step index. It has inverted parabola like structure. So that is the reason why I have defined n of r as n1 into square root 1 minus 2 delta into r by a power alpha in the core, and it is equal to n2 in the cladding. Refractive index of this fiber, graded index fiber, is constant in the cladding. Okay, and where n1 is the maximum refractive index of the core axis, and alpha is the grading profile index number. So this alpha is called as profile index number, which varies from 1 to infinite. So you can take this alpha from values ranging from 1 to infinite. When alpha is equal to, the index profile is parabolic and is preferred for different applications. So when in the application, when they use this graded index optical fiber, they are going to use this alpha as 2, which will give us as inverted parabola like profile in the core. Okay, so this is about the structure of this graded index optical fiber, right? So we have written the refractive index profile mathematically, which is having this in core, and it's constant in cladding. Okay, so propagation of light in graded index optical fiber. Right. As a light ray goes from a region of high refractive index to a region of lower refractive index, it is bent away from the normal. Right, we know that we have a core with higher refractive index and cladding with a lower refractive index. Right, as light ray goes from higher refractive index to the lower refractive index, there is going to be bending of light. Okay, so this process, the process continues till the condition for the total internal reflection is met. Okay, so in every optical fiber we have core and cladding. Core refractive index is always more compared to the cladding refractive index. Whenever the light goes from higher refractive denser medium to the rarer medium, there is going to be a bending of this light at the normal, bent away from the normal, and this process will be continued until the total internal reflection condition is met. Okay, so then the ray travels back towards the core axis, again being continuously refracted. The turning around may take place even before reaching the core cladding interface. Thus, continuous refraction is followed by total internal reflection and again continuous refraction towards the axis. So, in the graded index fiber, rays making angles with the axis traverse longer path, but they travel in a region of lower refractive index and hence at a higher speed of propagation. So, there is one advantage of this graded index fiber. In the case of step index fiber, the step index multi-mode fiber. So we know that step index, single mode step index fiber is having only one mode of propagation, and the numerical aperture is very small. So light gathering ability is very small, and it needs costly laser diode to launch the light. Coming to the multi-mode step index fiber, in multi-mode step index fiber, the core refractive index of the core is constant. So the rays that are traversing the longer paths are going to reach the output end with some time delay. So the information which you have sent is not going to reach the output end at the same time. There is going to be a time delay. Now coming to the graded index multi-mode fiber, it has advantage now that you have a graded index profile. In the graded index optical fiber, the refractive index is not constant in the core, right? So let me draw this. So yeah, so this is the graded index optical fiber profile. So in the core, the refractive index is not constant. It is maximum in the center and it decreases toward the core cladding boundary. So the rays that are traversing these longer paths, these at this distance, the refractive index profile at these places are small, because the rays that are traversing longer paths in which the refractive index is small, they are going to reach the output end with the same time as the rays that are traversing the smaller paths. So in this graded index multimode optical fiber, the rays, all the rays traveling through the fiber, irrespective of their modes of travel, whether they are lower order modes or higher order modes, they will have almost the same optical path length and reach the output end of the fiber at the same time. Right? So this it's clear now that the multimode optical fiber is the best one for the application, because the light rays can undergo total internal reflection, because even with the lower order modes and higher order modes are reaching the output end with the same time because of this refractive index profile. Right? So the rays that are undergoing total internal reflection, you can see clearly here. In the case of graded index fiber, the acceptance angle and numerical aperture decreases with radial distance from the axis. The numerical aperture of the graded index fiber is given by this. So we have defined the numerical aperture. I think it's needed to know what is numerical aperture. Numerical aperture is nothing but the light gathering ability. Light gathering ability of optical fiber is defined as numerical aperture. Right? So for these graded index fiber, which we found that they are useful in applications, because that in graded index multimode fibers, the lower order modes and higher order modes are going to reach the output end at the same time. Okay, and the refractive index profile of this, the numerical aperture of these graded index multimode fibers is given by these in simplified form: n1 into 2 delta power of square root 1 minus r by a power 2. Okay, so that is written as n1 into square root 2 delta into 1 minus r by a power 2. So this is the numerical aperture that decreases with the radial distance from the axis. So the numerical aperture is more at the center of the axis, and the numerical aperture is it decreases as we go away from the axis of this optical fiber. Okay, so to summarize this presentation, so I've discussed about these three different types of propagation of light and structure of the three different types of optical fibers, starting with the step index single mode step index fiber, right? Single mode step index fiber. So I've discussed the structure of the single mode step index fiber. So single mode step index fiber, so as the name suggests, you have the refractive index profile is like step index profile. So refractive index is constant in core, refractive index is constant in cladding, and if you draw this fiber, right, so you have a core, and you have cladding, and in this optical fiber you have only one mode, single mode. Okay, and we have discussed the structure of the single mode step index fiber, and we have also discussed the propagation of light in single mode step index fiber. We found out that the propagation of light in single mode step index fiber, the numerical aperture is very small, because there is only one mode for the propagation of light, and the ability, the numerical light gathering ability or numerical aperture is very small, and hence we need to use costly laser diodes for the launching of light. So yeah, so it's not very good for the application. So second one we have discussed about step index, multi-mode step index fiber, multi-mode step index fiber. So multi-mode step index, again as the name suggests, it has a step index like profile. Again the multi-mode step index, so you have constant core and constant cladding refractive index, and again here, so you have core and cladding. Here you don't have only one mode for the propagation, you have different modes. You can have higher order modes and you can have lower order modes. Okay, and we have discussed that about the propagation of light in multi-mode step index fiber. In multi-mode step index fiber, the light that is traversing the longer paths, basically the higher order modes are going to reach the output end with a time delay. So the lower order modes will reach the output end quicker than the higher order modes. So the information that we have sent through this optical fiber is not going to reach the output end at the same time. Okay, coming to the third optical fiber which we have discussed is graded index multi-mode optical fiber. Graded index multi-mode optical fiber. So in graded index multi-mode optical fiber, so we have discussed about the structure of the optical fiber. We know that's okay. So we have core, the structure. Coming to the structure, you have a core and you have a cladding, right? Yes. So here the refractive index profile is not constant in core. So it is okay. So this is the refractive index of core, and this is the refractive index of cladding. So the refractive index is maximum along the axis of the fiber and decreases smoothly towards the core cladding boundary. So this is the core cladding boundary, right? So this is the core cladding boundary. So it decreases the maximum in the along the axis of the fiber, and it decreases to match with the refractive index of the cladding at the core cladding boundary. So this is the structure of the multi-mode. So you can have longer mode, higher order modes, you can have lower order modes. So this is multi-mode graded index fiber, and it is very useful in the applications because even though there can be lower order modes and higher order modes, the time for the reaching the output end for the lower order modes and higher order modes is same. Okay. Because longer order modes, in the region of longer order modes, the paths that are long, the higher order modes are going to traverse longer paths in which the refractive index is lower, right? So that is they are going to travel with higher speed. So that is the reason why, because of this refractive index profile of this multi-mode graded index fiber, the higher order modes and lower order modes are going to reach the output and same. The higher order modes in multi-mode step index fiber, the higher order modes are going to reach with time delay, because the refractive index profile of the core is constant. But here the refractive index profile is not constant, of the core is not constant. The higher order modes, the region in which the higher order modes are going to take longer paths, the refractive index is small, and hence they are going to travel with higher speed. And hence both the higher order modes and lower order modes are going to reach with the same time, and here the light rays can now undergo total internal reflection, because the condition that N1 greater than N2 is also satisfied, because the refractive index is more at the along the axis of the fiber, and it is less as we go towards the core cladding boundary. Okay. So with this I am going to stop and with the about the discussion of the classification of optical fiber. In the next presentation I will discuss about the numerical aperture and acceptance angle, so on and so forth on optical fibers. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.